You're listening to Make Me Data Literate from the Australian Data Science Education Institute. I'm your host, Dr. Linda McIver, author of Raising Heretics, Teaching Kids to Change the World. Let's go change your mind about data. Welcome back to another episode of Make Me Data Literate. One of the great joys of this podcast is the wide range of people I get to talk to, and I have been pursuing this guest for some time, and finally we've got a chance to have the conversation. So very happy to have you here. Welcome, Ray Hilton.
Thank you. It's great to be here.
So let's start with the obvious question. Who are you and what do you do?
Yes. Well, my name's Ray, as we've already established. I'm a principal consultant and I specialize in data and AI. I'm also CTO of a women's health wearable health tracker startup called Kyrie. And I'm also advising a few different deep tech startups across like healthcare and climate. And I also do some research for space domain awareness at Swinburne. So there's a few things on my plate. And also in between all that, I have a family and fairly active weekends as well that I try and squeeze in as much as possible, burning a candle from every end using a flamethrower.
Do you eat and sleep at all? Because
they're overrated. It is a bit of a squeeze, but my supervisor said it best when he said he's got academic ADHD and he finds it hard to sort of sit in any one domain. And he's an astrophysicist by training, but is now like supervising people across like life sciences, especially like medical imagery, using AI for that. And there's a few other things like was it UIs, visualization, augmented reality, this kind of stuff. It's all, I guess this is once you get to that kind of level, you're able to pursue all your different interests under a single banner. But super interesting.
I've always thought that all the interesting stuff happens on the interdisciplinary edges anyway. So that really speaks to me. It's like I'm not interested in a discipline for its own sake. I'm interested in what it can add to other disciplines, especially computing. It's so obviously a service, sort of a service industry, a service discipline that, what can we do with it? What's the point? Where can we get some really interesting insights? That's really cool. You're also, I believe, one of the organizers of the Melbourne Deep Tech Meetup. How did that happen?
Well, that was it was just quite interesting because after COVID, obviously that put a bit of a dampener on in-person meetups, and post-pandemic, when things started opening up again, lots of them had moved online, and very few were coming back to being in person. So I think a lot of us, after being, isolated for so long, were keen to get back to face-to-face things, but not just in a work context, but with other people, peers who shared common interests. And I was trying to form one around space tech. Another friend of mine was trying to find one around biotech or life sciences in general. And I had another friend that was looking at it from a climate point of view. And we were like, hang on a second. These are all interrelated in a way. Like if we take a step back from the specific topic, what we're talking about is deep tech, this longer term transition of science. We try to say pithily, putting science into production. It's like these things originate in research. And then founders are taking that, understanding how they can map it to a product and going on this journey. And the deep part refers to the depth of knowledge as well as the depth of pockets required to be able to bring this stuff to fruition. So we put that together and we started, promoting it, and we get an interesting cross section of people. We've got, obviously students and academics, but we've also got business founders and people who are technical as well as more non-technical product people as well, and they all have this shared interest. So I think that, to your point about the cross-disciplinary, the intersection between these different areas, I think that's where this has hit very positive vibe is that people can come from all round different subjects, different domains, and yet they have this common shared interest of trying to sort of bring these this kind of research based ideas to light. And so we actually had an interesting example of this. Maybe it's a few months ago now, where we had one company come and talk, Mass Dynamics, who provide mass spectroscopy as a service for life sciences, and another company, Hone AG, who provide handheld grain and soil measuring, which also uses spectroscopy.
Oh,
And
wow.
so while one was agriculture and the other is life sciences, the technical underpinnings had a large overlap. And so the technical people from both teams started chatting and go, I didn't realize you were using it in that way. That's interesting. And so, that's what we hope, is that these people meet others who are doing interesting things that they may not have known about before. And through that, rising tide lifts all boats. We hope that we can interconnect these people, and interesting things come from it.
That's fantastic. So it's all about connections and about impact, doing real stuff with these research ideas. I love that. That's awesome. Your specialization is data and AI. What did you have to learn to do your work, and how much of that came from your formal education? How much you self taught? I hesitate to use the term specialization with someone like you, but nominal work specialization.
Yes. My specialization is my generalism. So yeah, jack of all trades, master of some, maybe. Well, I don't think I ever formally trained in this area. I do have a computer science degree, but I only got that after working in computer science, so it's a bit of a retroactive qualification. Um, but it did help. It certainly helped me appreciate computer science from a more fundamental science point of view, rather than just as a coding websites or whatever I was doing at the time. It exposed me to a whole bunch of other languages and platforms, and some of the history, like why things work certain ways. So I think without the computer science degree, it's certainly possible to learn this stuff on the job, but you're less likely to, let's say, learn MIPS assembly language on the job, because it's just not something that's necessarily in demand or people want to do. But it's an interesting experience to go through to understand, okay, this is actually at a low level how this computer works. And that's why we have, obviously, higher level languages, which are then ultimately compiled down to this. And so then you can appreciate, when I write code like this, it's going to turn out to be code like this in the in the assembly language. So the compiler's responsibility is to try and work out what your intention is and write the most optimal assembly language. But sometimes it doesn't get it right. I mean, these days, compilers are pretty awesome, and they're really good at this. But back in the day, you had to be mindful that if you wrote that tight loop or did this thing in that particular way, this is the impact it's going to have to how the assembly language comes out. And so to debug the performance or whatever it may be, having that lower level knowledge can help in some way. But yeah, I think I originally started my technology. I remember my dad buying a computer when I was about, gosh, I can't remember. Maybe it was about 7 or 8 years old. He bought this computer, and it was an Einstein. It was back in the time when everyone had their own little brands of computers with their
Yeah.
own operating systems.
Hmm.
They weren't all PC clones. I
I
think
had
it's
a
called an
Commodore
Einstein.
64.
Yeah, you had a cool computer. I had one. It didn't have much software support on this platform, and I think later we got a ZX Spectrum, and so then that was my one. And then I spent a lot of time like writing code in BASIC on there and trying to sort of make games and build out various different little silly little things. Like you could I can't even remember what I used to do on it, but I love playing around in graphics in BASIC and just like trying to plot stuff on the screen. And it was actually an interesting way of learning other topics. So when I started learning about uh, in physics, when we're learning about vectors at school, I was like, oh, I've been trying to draw a spacecraft that moves around
Mm.
the screen, and I'm going, oh, if you're going this way, you move forwards by this many pixels, and if you turn left, then I'll go this way by that many pixels. But if I just represent this as a vector, I can sort of dynamically calculate the orientation and the number of pixels, and then it's much smoother and it acts more like a real thing. And then I can apply another vector to act as thrust. And so, like, it actually helped me learn some topics like physics at school by going home and trying to implement some of the maths in code. And so
That's
I actually found
amazing.
it a great learning tool in that regard, back
I
to the
love that.
interdisciplinary aspect.
Yeah.
Um, but
So how
I think like these days, obviously, computers have come a long way, and it's much easier, I think, for kids to jump in and sort of learn like different languages, visual coding, things like that. And so it's much more normal to use computers as a teaching tool to explore things like physics. Yeah,
did you
sorry, you were saying.
did you teach yourself the data and the AI parts? Did they kind of happen just as part of your job and you learnt them on the job, or where did they come from?
Well, I think it was around the 2004-5 mark, which is a long time ago now. I did this computer science degree, and part of that was there was a module on AI, but it's not AI as we think of it today. It was like
Yeah.
simple neural networks, like a Conan network, and it was it was a really interesting topic because I guess it was the first time that I'd really been introduced to um, these ideas of like for this like the example they gave was put in RGB values into this Conan network, run it through a training process, and even though you randomize at the beginning, it ends up sorting the colors. And so the great thing about it is that you can visually see how it's sorted the colors into this kind of looks like a gradient, But every time you run it, it's different
Hmm.
because you start off with random, and all it's trying to do is bring colors that are close in value together. And it's a great teaching tool in that regard because then you can like run it and visually see the output and play around with it, and you can build the whole thing end to end yourself in just like not too many lines of code. And so you kind of have this, that intrigued me because I was like, oh wow, this is interesting. I can build this notion of a neuron and how it is like this fundamental component, and I can wire it up in this way, and I get this effect. But then if I wire it up in a different way, now I can build different things, and obviously it as a sort of foundational concept that like suddenly you have this paradigm shift of like, wow, what else can you do? Um, there is a generalization theorem that any function can be generalized as a sequence of polynomials, which is effectively what a neural network is. And so that's really interesting that, that's why these large scale neural networks can approximate very, very complex things, because you don't actually need to know what the function is in traditional software engineering. You start off with, this is how the algorithm is going to work, and I'm going to write the code. But obviously in a neural network, it can be learnt. And if the network is large enough and complex enough and there's enough data, you can pretty much do anything. Like you can synthesize, entire songs and based on examples of other people's songs. So, and it's really technically a function at the end of the
Yep.
day. And it's quite fascinating how that complexity can come out of what is just a sequence of polynomial expressions, really. It's the very high dimensional space, but it's fascinating. But to answer your question about like learning that stuff, like I did that in that comp sci degree, and then
Yeah.
I went on to do more and more data engineering as part of my day-to-day software engineering work. Data obviously came around, and so doing more data engineering and learning how to sort of efficiently manipulate it and build upon it. And it wasn't actually until a few years later that I ended up working at a data and AI consultancy, which was an interesting experience because it was a brand new type. It was a brand new company at the time, And the industry wasn't like it was today, where everyone and their dog wants a Gen AI prototype. Back then, no one saw the value in it, and we had to sort of spend a lot of time convincing people that there was value in that data, and we could extract some of it through machine learning or AI techniques. And then that was the first time that I really started using a lot of these like data science and AI techniques on the job. And then since then, I've done a few other things, but the recurring theme is data is now at the forefront of both product development and also how businesses work. And especially in startup spaces, you're looking to, be as efficient as possible, whether that's understanding your customer or understanding the business itself. You want to make sure that you're doing the right things, and you're mitigating, reducing risks, identifying potential revenue, and all that kind of stuff. It's all just data at the end of the day.
Yep. And so you've
Mm.
done, it sounds like you've applied a reasonably rigorous sort of scientific approach to your data analysis and your machine learning. Do you have feelings about the uh, the generative AI scene and the kinds of uses that we're seeing now, and the people leaping on board without necessarily knowing why they're leaping on board?
Yeah, I guess fundamentally, my concern is we want to avoid another AI winter. There's there's a chance that the reality if the reality doesn't match up with the hype,
Mm,
then people will become disappointed, and then that will lead to a reduction of investment, or at least a more conservative investment in these areas. And I think many people would say that that point is coming. The bubble will burst.
yeah,
Um, it's not to say that it will necessarily be a winter, but it might be harder to raise money just on the promise of having a .ai suffix in your business name.
yeah,
Um, but what we don't want to do is that the world is poisoned so much that people actively turn away from it. And so I think that's where we need to hit this very careful balance between talking about the potential of something versus overhyping it to an extent where it cannot be ever satisfied, and potentially send us back into a winter for another decade or so.
yeah,
I don't necessarily think it will go that far, but some of the claims around Gen AI are pushing us too far in the direction of all this talk of AGI, artificial general intelligence, like human-like flexible intelligence across a number of areas. It's like it, I understand obviously why people want to do it. They want to create excitement in this area, but it is probably quite a while away, and
yeah.
it's bordering on some sci-fi claims. And of course,
Mm,
maybe even ChatGPT would seem like sci-fi for someone from a few years ago,
yeah,
and so things do progress, but it's hard to see how all these things that are being talked about can be fulfilled in such a short space of time. The reality, I think, of Gen AI can be seen in like various projects we do, like for prototypes. Um, Someone plays with ChatGPT or they play with an example chatbot and they go, "Oh, this is great. This is interesting," and then they want to use it in their own situation. But once they look at the effort involved of trying to take what they see as a free tool, or at least a very cheap tool, and then customize it for their particular domain and do all the additional work, it suddenly stops being a free tool and starts being quite a large, not just a large initial project to build and deploy it, but also an ongoing cost in terms of maintaining it, retraining, but also things like access control,
mm,
operational monitoring, all these things that potentially we don't consider. We're just like, oh yeah, we type in the chatbot gives us an answer, but there's all this other stuff. If you want to productionize it and make it reliable, It's just like any other software project. There's all this infrastructure and stuff that governance that needs to go behind it as well. And so then all of a sudden, the cost of it becomes larger,
Yep.
but then value. Okay, some businesses manage to deliver a product that makes more sense around with Gen AI, but sometimes it's like this feature on the side. And so when it's actually deployed, some people might use it initially, but unless it's really offering value, significant value, or a significant new way of exploring your product, it may only remain that way. And so like the total, the cost benefit, it often doesn't make sense. And you link that with the other risks of, I think there's Canada Air suffered this, where their chatbot just made up a policy,
Yep.
which they were then found that they had to honor.
Yep.
So I think when risks like that start popping up, that obviously people hear that and they say, oh, okay, if we're going to build a Gen AI project, we need to make sure that doesn't happen. But listing all the things you don't want to happen is quite tricky. Like you can't simply say to the chatbot, oh yeah, and don't do anything I don't want you to do. There's this tension between having something that's flexible and works in natural language inherently means there's a generative element to it.
Yep.
And the generative element means that it is going to make stuff up.
Yep.
And controlling that and keeping that under wraps and not letting it go off piste is actually a really hard thing. And it's a long-term project, and you're going to constantly need to change it because the model keeps changing, user behavior changes, the prompts change. So you have to constantly reevaluate all these negative cases as well and put in guardrails that defend against it. So yeah, it's a much larger money pit than people realize. And there's even another aspect, which is that it's currently massively subsidized via, essentially hype funding, where
Yep.
there's been so much venture capital poured into Anthropic, OpenAI, etc., which is essentially covering most of the costs. But if you have a look into the stats around some of these things, both in terms of like energy consumption and like cloud computing costs, these things are hungry beasts. They use up a lot of energy and therefore a lot of cloud computing costs. OpenAI, had that relationship with Microsoft to provide a lot of that stuff at cost or below cost, but it's not being passed on to the general consumer.
Yeah.
And so down the track, if that funding doesn't continue to happen, these businesses will have to pass those costs on to the end users. And so anyone who's built things on top of these platforms will then have to face a choice of either how do they pay for it?
Yeah.
It changes that cost benefit calculation, or they try and spin up their own self-hosted AI solution. And then obviously that increases the halo effect of the cost complexity increases yet again if you have to in-house it.
Yep.
It's a very long-winded answer.
Not to mention water. Yeah, it's going to be interesting to see how all of that plays out. Is there something that you wish everyone knew about data? You do consulting and you work with companies who want data stuff but don't necessarily have the expertise. Is there something that would make your life easier if everybody understood it from the start?
Yeah, it's a good question. I think on its own, like data is relatively inert and doesn't really have much value. Like the value comes from what you do with it and how you interpret it. And it can obviously be interpreted in many different ways. We used to, as an industry, I think we used to have this philosophy of just collect everything you possibly can and we'll work out how to monetize it later.
Yep.
But that sounds great on paper because data is cheap to store, but the process of capturing it and then interpreting it can get very, very expensive. So I think now we're in a position of maybe we've refined and matured as an industry, but we're much more likely to say, don't collect everything. Let's think about this. Let's think about obviously things like PII. I don't want that going into long-term storage. I want
Can you
to
explain
scrub
that
all of
for
that
our
data as much as
non-technical?
possible. Oh, PII,
Yeah.
personally identifiable information. So we've seen, over the last few years some big data breaches, And this is an example of the more data you collect in one place, and especially if it has that kind of identifying information in it, the bigger the honeypot you create. And
Yep.
so eventually, if these things get hacked and exported, not only is that critical business data, but like identifying information about, let's say, you know, it could be healthcare information. It's not just the fact you've identified these people. It's like you've identified them and associated them with this, treasure trove for a hacker,
Mm.
information about their health history. So that's a terrible situation, obviously, and we don't want that to happen. And one of the easiest ways to avoid it happening is simply not collecting the data in the first place.
Yep.
And there's this tension between that, like how the most secure system is one you cannot access or has nothing inside of it, right? So there's a tension between that and the practical reality that we do need some data.
Mm.
Yeah. So I think these days we're a bit more nuanced about it. We try and think about, we try not to identify things. We try and scrub things that are identifying. We maybe use something like a differential privacy where you can remove or randomize certain data while keeping a consistent statistical shape to the
Yep.
overall data in aggregate. And so and that takes thinking and that takes work. And because we're cautious about the risks of amassing too much data, we're now shifting left a bit and not just, like I say, not collecting everything blindly, making more decisions about it, but also that impacts how we're going to use the data. Because if we don't collect as much data or we're scrubbing this information, it means we cannot answer certain questions later on. So we have to be a lot more mindful about this whole process
Yeah.
rather than just collecting everything and working it out later.
Yeah.
Um, yes, I think it's not quite a data question, but when going back to the Gen AI question, it's also the data used to train things is inherently historical. So what
Mm.
you're really doing is looking backwards, as it were. Like you're using the past to try and predict the future, but that's obviously there's limitations to that. And so as much as we can build very, very clever Gen AI things which can generate images and text, really what it's doing is piecing things together, synthesizing things based on historical data. So
Mm.
one could argue that there's not really anything technically new being generated. It's just a combination of other things that have already existed. And so you can see that in like style transfer, where images are created in the style of an artist, and it's using examples of that artist combined with knowledge of cats or whatever to generate a new image. Um, and so, but it's not really creating something new. It's not really thinking about it. It's not conceptualizing it. It's not uh, contributing fundamentally new thought or ideas. And so I think that's an important thing to keep in mind, especially when people are using like these Gen AI chatbots, is that when you're asking it a question, it's really just predicting what is the most statistically, what's the best word to come after the word I just put here. And so
Yep.
that's all it's doing is chaining together these words, or in the case of an image, pixels or whatever it may be. And so it's, from a Turing test point of view, it's like it perhaps it passes that and it convinces us that it's actually a thinking, feeling agent capable of conceptualizing what we're asking. But under the hood, it's just this probabilistic. So what's the phrase there? The stochastic parrot.
Yes. Yeah. And I think
A
that's
very
something that people.
convincing stochastic parrot.
It is. It's extremely convincing, but it's really interesting when you start hitting up against the edges of it. I was exploring. A friend of mine tried to use the image generators to generate a three-legged puffin, and it was so clear as you kind of go through the different prompts she used and the different sort of attempts, so clear that it can show you a puffin because it's seen pictures labeled puffin before, but it has no concept of what a leg is or where it might realistically be, and so it can't give you a three-legged puffin. It hasn't seen a three-legged puffin, and so there's just no understanding there. There's no, I can give you what you ask for because I understand the pieces and I can put them together in a way that a 5-year-old could could sketch a three-legged puffin, and it'd be a bit rudimentary, but but they know what legs are and they know what birds are, and they can put the ideas together. Whereas this can just give you things that it's seen before in slightly different um, arrangements, which is something that I don't
Yeah.
think we really intuitively understand. I think we don't want to understand it. We want them to be intelligent in some sense.
Yeah, I think a good example of that is the new video generation. And I'm sure we've all seen examples of the very uh, trippy psychedelic videos where there's no coherence, and
Mm,
so each frame is being uh, interpreted individually. And so, like as the video progresses, things that weren't anything in a scene suddenly manifest into a person or a dog, and then transmutate. And there's no in those examples, because there's no underlying concept or continuity.
mm,
Every uh, bit of noise or shape could then be subsequently translated as something completely different. So that's what creates this kind of dreamlike psychedelic kind of video. But modern ones have better coherence in time, but you can also see how they struggle with physics.
mm,
So if you're generating something new and there's an object, let's just say it's like a car crash or something like that, it's seen examples of that from movies and it can generate some of it. But you'll notice that the physics will always feel off and not quite right because there's no underlying understanding of how the physical world works.
yeah,
It's replicating images from videos. It's not replicating the underlying mechanisms that cause it to happen. So yeah, I think sometimes those edge cases are telling about how the internals actually work. But for the vast majority of cases, if we're just generating something like a fun image of a puffin with three legs, maybe what it's producing, you're not asking it to do something that's necessarily photorealistic or a real
yeah,
world thing. You're asking it to do something which is crazy and not really seen before. So this kind of creative interpretation is perfectly acceptable.
mm.
But yeah.
Um, we've been wandering around AI, and I've lost sight of the questions a little bit, but it's been super interesting. Um, what are the worst data mistakes you've seen?
Well, I think obviously, as I mentioned before, these big data breaches are probably like one of the larger risks to happen. Like when you're amassing data, especially
Mm,
private data, that's one of the risks that can happen. And yes, there are fines associated with it. There's loss of trust in a brand. But obviously, the big impact is on the individuals who
yeah,
potentially are now, you can't claim that data back. You can't
yeah,
scrub it once it's out there.
yeah,
And so now when the was it Medibank breach occurred, I think there was like they were providing free new driving licenses or things like that so that people could their old ID was scrubbed. But that obviously doesn't
yeah,
get rid of the old information. The information that's already out there
yeah,
doesn't get rid of all these medical records associated with their identity.
yeah,
So it's like it's not enough. And the best, like I said before, the best thing to do is just either not collect avoid collecting stuff you don't need to collect and don't collect it for any longer than you need it. And
yeah,
also, and this is a good recent thing, consent. Like, don't use people's data willy-nilly. It's like you
yeah,
only if people opt in for that specific purpose for that specific period of time.
yeah.
And then that way they have at least a degree of control over when their data is being replicated or used for something.
I,
But and I think the general public are much more aware of these things now, and because of these incidents, and so they demand that companies notify them
mm,
more so when their data is going to be used.
mm,
And we have seen examples of now if a company goes and uses customer data to train its AI models on private personal data without the customer's knowledge. That is
yeah,
now an outrageous thing to do, and they get there'll be media articles about it, and that's a good thing. At least we're holding people to account and we're raising that as an issue now. Whereas in the past, I think nobody would have even known.
yeah. It is complicated though, and I think our understanding is still lagging behind the industry behaviors. I was in a medical appointment recently where the doctor said I use AI to transcribe my appointments, um, but it's fine because I delete it after 2 weeks, and it doesn't keep the audio. It just keeps the text, and I delete it after 2 weeks. It won't be in the system. But I went and looked at the privacy policy of the system that she uses, and it clearly states that it reserves the right to share your personal data with third parties and its software developers and whoever it wants, basically for the
Oh,
purposes
God.
of improving the system. So she says it's deleted after 2 weeks, but it's in the training. It's in the and they reserve the right to share it with anyone. And I don't think she knew that, the doctor, and we certainly weren't informed of that as the patients in the appointment. And I don't think most people would know the questions to ask to drill down to what's actually happening with their data in that situation. And that's going to come out, and that's just outrageous.
Yeah, it's a fundamental issue of who owns your data.
Yeah.
And I think most people would assume they own their data, but it seems most companies, well, many companies in this space can get away with laying claim to it and then moving it around as an asset.
Mm.
And I fear without adequate legislation that puts the ownership squarely in by default in the hands of the citizen, and they
Yeah.
have to actively opt in and give consent for it to be used in certain ways. Without something like that in place, it's doubtful that companies are going to change their behavior around this too much. And
Yeah.
we
I
do need
completely
like a
agree.
common framework for dealing with this.
Mm. We do.
Um,
For which we
it's a
need
complex
legislators
beast.
who understand it.
Yes, yes, yeah. And I think this recent trend in obviously like the AI, but Gen AI specifically, where they're training on basically the internet.
Yeah.
So comments and on Reddit or discussion groups, things that may have just only existed there and you'd find it in a Google search, but now makes
Mm.
up a part of the training corpus of these
Mm.
large language models. It's like that person wrote that comment with the intention of replying to someone on some comment thread somewhere.
Mm.
They didn't write that comment maybe 10 years ago with the intent of it then being used to contribute to building this product,
Yep.
say ChatGPT.
Yep.
That was their intent. They didn't consent to that.
Yep.
But I guess somewhere down there in the terms and conditions it says Reddit's allowed to do that. Or Google will come along and just like scrape the whole internet. You know, this has happened before. People are annoyed about Google scraping the internet and indexing things and displaying
Yeah.
search results. So I think French news agencies were upset about that back in the day. And this is like another iteration of that. So now other products are now being built on people's uh, public data, but
Mm.
does public mean it's up for grabs?
Yeah.
Like just because you wrote it in one context doesn't mean to say it's legitimate in another context.
Mm.
Yeah,
And
complex.
I feel that the things you tell your doctor are not public data.
Yeah, that's. I think
That's it.
it's almost there's a leakage from the mentality of how we treat public data
Mm.
into things like that. Oh, if we scrape enough data from enough places on the internet, we can build this.
Yeah.
If we want to build a model for private data, oh, we'll just scrape all the private data and put it into one place and do it there.
Yeah.
And it it kind of skips over the part where who's this or how do you retain privacy in all
Yeah.
this? What about the individual user? It's their data, that's their life you're dealing with there. There are techniques to like find a balance, like federated learning, for example, where I believe Apple do this, so they can learn on device. They can use like your photos or your messages and things like that, and they can learn. But then they take the weights and biases from that, and so without exposing your data to the internet, your data retains on your device, and they
Mm.
can just like learn for some like classifications and things like that. And they can upload that, and then that is combined with everyone else's data along with some other um, core models, and that creates a new model. and so then that way you can learn from people's personal information without exposing their personal information from their device. And
Yep.
so there are things that you can do like that. So you can still do ML without compromising privacy, but it is much more complicated.
Yeah.
And you know, obviously, people end up wanting to do a cheaper thing, and that's the motivation there. But if legislation was put in place to motivate people, there are options out there. It's not like it's impossible.
Yep. Yep. It's definitely, it requires legislation. I don't think we can. I think we've seen very clearly over decades really that we can't expect companies to act in society's best interest unless we force them to. Have you ever seen data deliberately misused, and what do you look for? How do you spot it?
Not on a well, I guess there are cases where it has been famously deliberately misused. I think a good example is like the Centrelink fiasco, where that people's data was being used to make probabilistic assessments as to whether people were owed money, and
Yeah.
then sending out demands without a human in the loop.
Yeah.
And so someone obviously designed this and signed off on it and put it into production. And so people can point fingers as much as they want. The fact is, it happened. It was a misuse of data,
Mm.
a callous misuse of data,
Mm.
with no thought. Well, maybe they did think about the individuals involved, but they were optimizing for cost recovery,
Yeah.
not what's best for the individuals. And so I think that's a shameful misuse of data by our government. So maybe that puts another side to the legislation thing. Is that it's like the people who are going to legislate it are also the misusers of it.
Mm.
What does that mean? But I think that's particularly egregious, that one, because these are people who are supposed to be in a position of trust and
Yeah.
authority, and if they cannot be trusted, it leaves a very sour taste as to like, well, what else is going on? The government has that ability to have huge amounts of data across any number of different areas.
Mm.
Do we just have to wait until there's a whistleblower or a leak until we find out the next thing? Like, how many
Yeah.
other things are going on like this?
Yeah.
So I think if for nothing else, even if there is nothing else going on, the fact that it does not help in the fact that it sows a level of distrust between a citizen and their government, and that is just not necessary and not constructive in any way. Yeah, I don't think the data was collected with that intention in mind. So that's the other thing, is that
Mm.
the data was there,
Yeah.
and someone looked at it and said, yes, we can use this data to do this thing.
Mm.
So that's
Comes back to
yeah,
consent, doesn't it?
comes back to consent. I think there was something recently where a medical imaging startup was using customers' medical images to train a
Yes.
machine learning, and that again was without customers' consent.
Yeah.
And so that's been in the media recently, and
Mm.
that's an interesting one. I'm sure somewhere in their fine print they say, oh, if you give us your images, then we're allowed to use them for other purposes. But
Mm.
putting it in the terms and conditions is very different from getting people's enthusiastic and positive consent.
And
It's
informed.
like informed consent. Yeah, like people need to have a full understanding of what something is. Otherwise, can it really be considered consent if
Mm.
they don't know what machine learning is, and they don't know what this AI model's for, or they don't know what they're not even aware that this is another thing a company does.
Yeah.
But they can't consent if they don't know those things.
Yeah. Yeah, it's
Mm.
like consenting to an operation, and then the operation you think you're consenting to is an appendectomy, and they decide while you're in there they're going to take a leg. It's like it definitely requires a different consent form.
Yeah.
What's
While we're
the
in the area, we thought we'd do a few other things. Yeah.
Yeah, exactly. It's like, no, I'd like to. to be involved in that conversation, please. Yeah, we have a lot to learn, I think, about consent where data is concerned. What's legal and what's ethical are not necessarily the same thing.
Yes, absolutely.
What's the first question you ask when you look at graphs in the media?
I I think I saw a good example of this the other day. I can't remember. It was a station in the US, and they had a graph of um, user opinions,
Hmm.
and it was like yes, no, maybe, don't know. And the 13% result was the largest bar, and the 22 and the 25% ones were really small.
Oh,
And
ah, it
they
burns.
so there was no real y-axis. The,
Yeah.
the vertical amount was what fit the narrative, and it
Oh,
was a particularly bad example. There was no y-axis, but that would be my answer: is what is the axes? What
yeah.
are the axes? What are they saying? What is the scale? And there's a I did see another one the other day. I think this is from in Australia, and I can't remember what it was tracking. It might have been COVID cases or something like that. But the y-axis went in steps of, I think it was tens, and then 30s, and then 50s,
Yeah.
and it
It's creative.
wasn't like logarithmic or anything like that. It was just
Yeah.
kind of like they obviously had a maximum number, and then they fiddled around with the y-axis to make
Yeah.
the graph look a particular way. It's like, oh, it's such a dishonest practice.
Yeah.
And I think a lot of people, well, especially when you're flashing something up on the screen on the
Yeah.
TV, they're not, you're not sitting there pausing and analyzing the graph. You're just kind of
No.
like, oh, well, visually that thing's bigger than that thing. That must be
Yeah.
bad
Hmm.
or good, depending
Yeah.
on what they're trying to say. Yeah, so I think that's a that's a hard one. I think it's different if it's in print or
Mm.
or online, because you can sit there and you can study it a bit more.
How
It's not
many
just
people
flashing
do
up on the
though?
screen.
That's the question. How many
Yeah,
people do, and how many people know what questions to ask? That's part of why I do what I do. What excites you about
yeah.
data?
I think there's a lot of potential in using data for solving some pressing pressing challenges. Energy, climate, agriculture, food security. It's We need to be more efficient. We can't be so wasteful with things like energy or produce, and
Mm.
we need to be efficient. Like, sure, we can buy electric cars, but the better thing to do is maybe not have cars as
Yeah.
much,
Hmm.
right? More public transport. But these are logistical problems. What's the best routes to have? What impact does pricing have to adoption of public transport? Like,
Mm.
how busy does a tram need to be before people won't get the tram and they'll
Mm.
drive their car instead? Things like that. So if we understand all these factors and we can do some predictive modeling, we might be able to come up with better policies. I mean, personally, I think we should have free public transport.
Yeah.
But modeling this and seeing what the impact is and how much it will change things, we could potentially impact climate, energy, and and a healthier workforce as well
Mm.
by doing policies like that. So it's a multifaceted impact. But
Mm.
yeah, data helps us look across all those different areas, and it's a tough job, right? We
Yeah.
have to model all these different things and pull it all together, but it is possible. And I think that's the power there. Like I said before, like data itself is inert, but it's the what we do with it and how we model on it and how we can use it to solve these problems is definitely where the value lies in how we apply it to these things. And I think efficiency is a big thing. Like we always talk about, we want more power,
Mm.
more energy generation. There's like discussions about new power plants and whether we should have more power plants. Oh, we need more coal power plants because we need more energy. Okay, on the one hand, we might need more energy, but we should also be very conscious about how we're using energy.
Mm.
And simple things like we have huge amount of rooftop solar, but we don't have many batteries. So that means we've got lots of free energy during the day.
Mm.
So simple things like use your energy hungry devices like the tumble dryer during the day. when there's
Mm.
plenty of sun. And so then you're more likely to offset that energy cost. As soon as you use it at night, you're going to draw power from the grid, and therefore probably coal
Mm.
in Australia. So there's things like that where partially it's educating the public, but it's also like, again, it's kind of a logistical thing of like trying to work out and model the best time to use certain types of power. Oh, it's particularly windy today. That means that wind farm's going to be generating more power, which means that this is how we should use it, and this is how we should proactively adapt to using the power as it's available. So yeah, I think I'm overall optimistic and excited about using data in those areas a lot more. And it also draws on many different, going back to the interdisciplinary thing, it draws on so many different areas of science, like modeling so many different aspects of the world
Mm.
In order to build these kinds of ensemble solutions, like to sort of think of simple things like an individual's behavior in that place with that kind of weather condition. Well, there's a cohort of people like that,
Mm.
and together they're going to create a spike in demand at this time of the day in that region. And there's so many different things you need to model just to have that one prediction. And so
Yep.
we can map this out across the entire nation and look at different areas. We can also look at the climate impact from that as well. Yeah. It's not a simple undertaking, but it's definitely deeply, deeply fascinating.
Thank you so much. This has been a fabulous conversation. I love the way every one of these goes in a different direction and brings up a whole range of new issues. It's been really interesting talking to you. Thanks for coming.
Thanks for having me.
Thanks for listening to Make Me Data Literate. If you'd like to support the work of the Australian Data Science Education Institute, you can donate at givenow.com.au/ADSEI or via the ADSI website. Let's change the world together.